Hi, Jason with Tormach. Let's talk about mold machining. We have our 1100M all set up to machine a mold for a carbon fiber layout. This mold will be used to make custom intake tubes for Corvettes. This is a large part. We started with an 18 by 8 inch by 6 inch block of aluminum that weighed about 87 pounds. The 1100M has 18 inches of travel in X, so we definitely needed all the machine to be able to make this part successfully. So let's talk about how we manage the part size and the finishing strategies we used while we were cutting this mold. So here you can see the block of material. It's sitting on the scale at 87.2 pounds. We loaded this thing up in the 1100, mounted it on a fixture plate using the modular clamps, and then we loaded up this new 1-inch mini shear from AB Tools. This is a 3-flute roughing tool from AB Tools that's designed for cutting aluminum. So we wanted to put this thing through some testing here with this big part. We actually ran this tool in this roughing strategy. It was a little over 3 hours total. There's a lot of material to remove on this side of the part. So we went ahead and worked through it. We ran this thing at, ended up being right about 1,300 surface footage at 5,000 RPM and a 5,5/10 chip load, which worked out to about 83 inches a minute. We were taking a 300,000 step to cut and 125,000 step over. And you'll notice we use a both ways adaptive roughing strategy on this. It saved a tremendous amount of cycle time on this part. Just being able to cut both ways and literally cut cycle time in half on this one. On that strategy, we went ahead and we lightened up the width of cut, but we kept the feed rate the same. So our width of cut we turned down to about 100 thousandths on the conventional side, but we left the feed rate and everything the same. We tried to lean on it to get some efficiency out of it. We also wanted it to be, safe and have a lot of process reliability with this tool path. I didn't want to stand in front of the machine and watch it rough for over 3 hours. So we got it running, was happy with how it was cutting, and we walked away and we just let the camera run and let the part finish roughing. We did have a fine step down on this part, so we had that 300,000 step to cut, but our fine step down was at 50 thousandths of an inch. So you'll see we get the nice smaller scallops on this, so we can come back and do the semi-finishing and stuff a little bit easier. We'll go ahead and let some of the roughing footage and stuff play. As I mentioned earlier, one of the challenges of this was the part's the same size as the machine travel. So we had an 18-inch part on 18 inches of travel. Tool pathing was a little bit interesting because we had to contain that tool path in the x-axis, but we had enough travel in y to be able to run the tool off the side and everything. So we had to create some boundaries on the side of the part. We just drew a couple basically big rectangles on the side to keep the tool path out of that area. And that ended up working really well for us. As you can see, as it's cutting and stuff, it worked through and it actually started in the center of the part. Ideally, we would have liked to start on the outside of the block, but just to get this to work and get the tool path to lay out correctly, that's where it ended up starting for us. The machine and everything handled it just fine ramping into the part. I would have liked to have been able to play with it a little more to start on the outside, but sometimes if it's working, you just kind of let it run just to keep everything moving. Once we got done with the 1-inch roughing tool, we came back with a 1/2-inch diameter mini shear. So this is a single flute cutter that uses the same insert as that larger 1-inch, but we're able to go all the way down to a 1/2-inch diameter with this. But we were able to run this tool at 7,500 RPM at 5,3/10 per tooth chip load. And it's a single flute, so that worked out to about 40 inches a minute. And we ran this at 100,000 step to cut again and a 50 thousandths width of cut. And then we just went ahead and did a rest roughing tool path on this to pick out that bottom area but not re-machine everything that we already had done. Once we wrapped up with that 1/2-inch diameter mini shear, then we jumped over to our 16mm ball end mill. This is an inserted ball end mill, as you can see. We had to do a quick rest roughing routine with this one as well to go ahead and clean out the big radiuses in the bottom of that pocket a little bit. There's actually a full radius that runs right down the edge of the part, so we needed that ball end mill to be able to put that in. So we came back with this quick, did another rest roughing routine, again with an adaptive roughing strategy. We're able to run this tool at 5,000 RPM at about 50 inches a minute for roughing. Our depth of cut on this again was 100 thousandths of an inch. And the width of cut we set at 190 thousandths. Once we got those little pockets cleaned out, then we were able to come back and start semi-finishing. One of the important processes when you're machining a mold is when you're actually going for your final finishing passes, you want a real consistent amount of material on the parts, that the tool load is consistent, and then it just really helps you improve your surface finishes. So we came back and we did some semi-finishing. One of the debates is always what tool pass strategy is going to work best for my part. Should I do a raster where I just run back and forth? Should I do like a 3D offset style where it takes the profile and collapses down onto it? You know, there's a lot of variables there. What is my machine like? What is this part geometry like? And all that stuff really comes into effect of it. It's always kind of those things you argue with yourself about while you're programming the part. Some are, you know, kind and they lend themselves real obviously to what strategy is going to work out well for them, but some of them, you know, you could kind of go back and forth on what you want. I kind of cheated on this part. I ran it both ways. I did a couple test cuts, so I actually left some extra stock on my roughing, and then as I semi-finished it down, I started at 50 thousandths of an inch material on my rough stock, so then I could semi-finish it a couple times. I wanted to be able to see what kind of depths of cut the machine and the tool liked, you know, to get a good surface finish. When you're laying up carbon fiber or really any mold work at all, the surface finish of the mold is extremely important. Any little tooling mark, any little imperfection is going to show through in the final product. So I just wanted to give myself the best chance of success I could, so I went ahead and essentially finished the part a couple times. As you can see, the first time I did the semi-finishing strategy, I used the fog buster. This worked and it kept the chips clear. I did see some recutting. I did see a little galling on the surfaces of the part and stuff, that it wasn't clearing the chips effectively, and it was recutting them as we were doing the finishing. So after that, I did go ahead and I switched to the flood coolant setup, just to help flush those chips away and get a better surface finish on the part. So you can see I kind of finished it a couple ways. I did a couple raster passes that are just the straight back and forth. I ran a couple of them on a 45-degree angle with a perpendicular pass. I really just tried to play around with this and see what laid out the best. So what we ended up finding out is that on the mold cavity itself, the 3D offset style or a scallop style toolpath gave us a really nice finish on the walls and everything. It did have one little feature on it that I didn't care for, which it ended up leaving a line right down the center of the mold where the tool would change directions. It's a real faint line and stuff. You can definitely see it in the part, but it is there. But when we ran the finish pass as a raster style toolpath, it just didn't come out as smooth. The curves and everything and the walls of the part didn't look as nice. You know, the customer essentially was happy with that line being in the part to get a better surface finish on the outside. So as I mentioned, we ended up using that scallop toolpath for the finishing and that 16mm ball end mill again. We're able to run that a little bit faster on the finishing. We ran that at 7,500 RPM at 50 inches a minute on our finishing strategies. For the mold cavity itself, we ran a step over of 5/1000ths of an inch. And when we finished the parting surface on that, we did use that raster style toolpath again, and we tightened up the step over on that to 2,500. So here's the mold all finished up. I'm pretty happy with how it looked. You can see that little witness line down the center of the part, but all in all, that part looked really nice. We're pretty happy with how it looks. But as you can see, the whole back side of this thing, we didn't really show the footage of it in this video, but the whole back side of this part is scalloped out. You can see it a little bit here at the end when we're flipping it around. But so this mold ended up weighing about 13.5 pounds. It was definitely a fun project to take 75 pounds of material off of this thing and have a nice looking functional mold when we were done is definitely a lot of fun. You know, we took over 70 pounds of chips off this mold, and it looks great when we're done. We have a nice functional part. So thanks for watching. Hope you guys enjoyed the video. For more metalworking tips, tricks, and stories, check out our other YouTube videos, and please subscribe.